Hey, what are you up to right now? I guess you're sitting in your warm room, possibly eating some snacks. Maybe drinking tea, coffee or juice. Simple treats, huh? I bet. But as with everything on our planet, it's not as simple as it seems. All of this wouldn't be possible if, at some point, we didn't realize how to mine all the energy resources that bring us comfort and warmth in the modern age. For instance, oil and coal. Demand for them only increases every year, but the resources tend to run out. Not to scare you, but it's predicted that fossil fuels will be finished already in this century. Oil can last up to 50 years, natural gas up to 53 years. Coal, 114 years. So most probably our generation is safe. But what are we going to do next? Is there anything that can help us to create a sufficient amount of energy? Actually, there is. It contains a lot more potential energy than any fossil fuel. 1 ton of that material produces the same amount of energy as 50 million barrels of oil. Okay, just to be more clear, imagine 500 kilos of this material can produce 5 gigawatts of clean, ecological energy, 24 hours a day for 1 year for a city with around 3 million inhabitants. This precarious thing is called helium-3. So why are we still relying on gas, oil and coal? Well, there's one tiny detail that we haven't told you about. We can get that gas only on the moon. Humanity knew about this for some time already, and seems like that sparks another space race right now. Countries fighting for their place on the moon. Seems like a scenario for an upcoming blockbuster. But who can tell if that's already, in fact, the reality? I bet you have a ton of questions. I mean, this whole idea of mining on the moon seems strange, if not full-time crazy. Now, how exactly are we going to get that strange gas on the moon? We could hardly walk on the moon more than 50 years ago. And now suddenly we're going back there to start mining. Maybe it would be much wiser to search for alternative sources on Earth. Why should we spend ridiculous amounts of money on those kind of space races? Are we sure that the potential space mining of helium-3 will actually pay off? In this video, we'll tell you everything you need to know about the power of helium-3, what exactly humanity is doing right now to get it, and how the countries want to take over the one and only satellite of the planet Earth and its resources. Get prepared to learn everything you need to know about the space race of the 21st century. The new space race. Why do countries want to colonize the moon? Okay, let's start with the main question. Why exactly we can't just stay on Earth and search for alternative resources here? And why should we spend that much money? Wouldn't it be better to spend it on new hospitals, shelters? Why do we always spend so many resources on things we're not even so sure about? Well, here I would like to suggest diving into history for a moment. Just imagine this. It's the year 1803. The young nation, the United States. The Western territories are yet uncharted. The whole knowledge about those parts of North America was learned from the French traders, fur trappers, and also Spanish and British explorers. However, the president at the time, Thomas Jefferson, had a grand vision to explore the vast unknown. He hoped to establish trade with Native American people of the West and find a water route to the Pacific. Also, Jefferson wanted to uncover invaluable information about the natural resources and geography. And so he asked Congress for $2,500 to fund the exploration of the western part of America. Just a year later, in 1804, the epic adventure started. A team of volunteers led by Captain Meriwether Lewis and his close friend, 2nd Lieutenant William Clark, headed to the west. They navigated through uncharted territory, meticulously mapping the land, getting to know Native American tribes. They recorded 178 plants and 122 animals not previously known to science. After over 2 years of travel, the expedition reached the Pacific Ocean in November 1805, becoming the first American expedition to cross the continent. The Lewis and Clark expedition brought back a treasure trove of information that greatly expanded the understanding of the Western territories. Their detailed maps, scientific observations, and accounts of Native American cultures opened up new possibilities for trade, settlement, and westward expansion. It opened up the opportunity to build new settlements and a railway later on. Nobody knew what was going to happen with the expedition, but Americans took the risk and it was rewarded. Just like that, many great achievements in human history became possible because of our insatiable curiosity and our willingness to push boundaries. From medical discoveries to technological innovations, curiosity has always been the driving force behind our advancements. Taking risks and venturing into the unknown have paved the way for new discoveries and shaped the course of history. All right, that's true, but all of these things happened on Earth. Now we are talking about the colonization of the moon. I mean, that is a valid point. We didn't even explore the Earth fully. More than 80% of our ocean is unmapped, unobserved, and unexplored. Why exactly do we need to spend billions of dollars to explore the moon and get helium-3 there? Aren't there enough sources of renewable energy? Well, about that. Truly, in recent years, solar power and wind power have gained significant attention as promising alternatives to traditional fossil fuels. Obviously, they have a lot of advantages. They are clean, abundant, and have the potential of reducing greenhouse gas emissions and mitigate climate change. But despite all of this, relying solely on solar power and wind power as the exclusive sources of energy may not be a comprehensive solution to our needs. One limitation of solar power is its dependence on sunlight. Solar panels generate electricity when the sunlight is available, but their efficiency can be affected by many factors such as weather conditions, latitude, and time of day. In regions with frequent cloud cover or long winters, solar power is less reliable and efficient as a primary energy source. Similarly, wind power also has its limitations. Wind turbines require consistent and strong winds to efficiently generate electricity. In order to achieve a sustainable and reliable energy future, we need a balanced approach that combines various sources. And in that sense, helium-3 is just perfect. Okay, now finally let's understand what is helium-3 and why we so desperately crave it. Basically, it's a rare isotope of helium. It is different from the more common helium-4. It has one less neutron in its nucleus, therefore it's lighter. Now, the reason why helium-3 gained so much attention is its high energy yield and low environmental impact. When fused with another isotope, such as deuterium, it can release a tremendous amount of energy. Another big advantage, unlike traditional nuclear power, it does not produce long-lived radioactive waste that requires complex disposal procedures. Sounds perfect, but why couldn't we just find it somewhere on Earth? Well, and here comes the biggest disadvantage of this isotope. Tiny problem. We can't exactly get helium-3 on Earth. Yeah, not like we don't have it all. At least that's what the geochemical evidence indicates. But the majority of it seems to be very deep down in our Earth, in the core. At this moment, we can't get there. The temperature is too high and we don't have the technology to go down that deep. However, we do have the capacity to go to the space. Potentially, we can start mining helium-3 there, and fortunately for us, we can find this isotope on one of the closest space objects. The Moon. But how exactly did Moon get all the helium-3 and we have, nothing? Well, there's a very simple explanation for this. Helium-3 is emitted by the Sun within its solar winds. Our atmosphere prevents any of it from arriving on Earth. But the Moon is less lucky in that sense. Nothing protects it. So for billions of years, the Moon has been bombarded by solar winds containing helium-3. And that's how it has all those massive volumes of the precious isotope. Some estimates suggest that there are at least 1.1 million metric tons of helium-3 on the lunar surface. That's enough to power human energy needs for up to 10,000 years. But it's not all about helium-3. The Moon has another important resource: water. You've probably already heard that our satellite has water on its surface. NASA found evidence of water in certain areas on the Moon in the 1990s. Later they found hydrogen in soil samples from the Apollo missions. In 2020, NASA's SOFIA mission provided evidence that water is present on the sunlit area of the lunar surface. Another important discovery was made during China's lunar mission. Chang'e 5 lander brought back to Earth a soil sample in which scientists found H2O. But it wasn't in the form we're all used to seeing. The moon water was trapped inside tiny beads of glass. But however did water appear on the moon? If there was water, then isn't it possible that there were living organisms on the moon? Or maybe they're still there? Well, it's highly unlikely, but scientists are still trying to understand where the water on the moon comes from and how it behaves. They think that the water might have come from past and recent impacts by comets, collisions with icy micrometeorites, and reactions between lunar dust and the solar wind. However, further research is much needed if we want to gain a complete understanding of the moon's water history, current state, and future prospects. And we definitely need more moon soil samples for that. One thing's certain, extracting water on the moon will help us in our future space missions, and here's how. Today, space missions are launched from Earth. To enter the orbit, the spacecraft needs to be going about 11 kilometers or 7 miles per second, or over 40,000 kilometers per hour, 25,000 miles per hour. This is necessary to overcome the force of gravity on the planet. Any rocket leaving the Earth carries a supply of fuel to fly to its destination and, if necessary, to return back. And here lies the main problem. In some modern rockets, fuel takes up sometimes about 98% of the mass of the spacecraft. For example, for the 1967 Apollo mission, the rocket that achieved one small step for a man and one giant leap for mankind held just under 950,000 gallons of fuel. If scientists could refuel the spaceship in orbit, then it would be able to accommodate more people and cargo. Now, the force of gravity on the moon is 6 times lower than on Earth. This means that the rocket will need less fuel to overcome the gravity of our satellite. This makes the moon very attractive from a technical point of view, but what about water? Well, if we figure out how to extract the water on the moon, then it can be processed to produce hydrogen-oxygen rocket fuel. Basically, if we have a station on our satellite, then we can send the spacecraft from the Earth with the minimum amount of fuel. Then we can refuel the spaceship on the moon with the hydrogen-oxygen fuel made right on the spot. The construction of a refueling station will decrease the mass of the ship. Also, it will help significantly reduce the cost of deep space missions. And also, we will need much less fuel since the force of gravity on the moon is lower. No wonder so many countries want to have a station on the moon. So, who's going to be the first one to start mining helium-3 and extracting water on the moon? Well, humanity is set in the exploration stage. But even now, it's all giving new space race vibes. Do you remember the one we had before? Most of us don't, but well, history tends to repeat itself. The previous space race was a 20th century competition between 2 Cold War rivals, the United States and the Soviet Union. Each country was trying to achieve significant milestones in space exploration. Unfortunately, that also included the ultimate goal of landing humans on the moon. It began in the late 1950s when the Soviet Union successfully launched the first artificial satellite Sputnik into orbit in 1957. This event triggered a sense of urgency in the United States to catch up and surpass the Soviet Union in space exploration. The space race escalated with various achievements and milestones, including the first manned spaceflight by Yuri Gagarin in 1961. In response to these Soviet successes, US President John F. Kennedy announced in 1961 the goal of sending astronauts to the moon and safely returning them to Earth before the end of the decade. The moon landing of Apollo 11 in 1969 was a significant milestone in human history and a major achievement for the United States. The race ultimately concluded with the joint US-Soviet mission Apollo-Soyuz test project in 1975. That marked the beginning of a new era of international cooperation in space exploration. But now, almost 50 years later, seems like the game is on. Again. But this time, there's another big player. China. Its Chang'e program is a multi-phase mission to study the Moon's geology, topography and resources, as well as conduct experiments and tests for future crewed missions. The program has included orbiters, landers, rovers and sample return spacecrafts. However, other countries are also actively pursuing lunar missions, with plans for manned and unmanned missions soon. Russia will launch its first lunar space mission in modern times on July 13, 2023. It's also important to mention that in 2021, China and Russia announced they would be building a moon base together. But the USA and NASA never sleep. They have bigger plans with their upcoming Artemis 3 mission, and as NASA claims, it has a significant role for the whole humanity. Currently, the mission is scheduled for 2025. It will mark a historic moment as humanity's first return to the lunar surface in over 50 years. NASA's mission will explore the region near the lunar South Pole, opening up new frontiers in lunar exploration and paving the way for future space exploration endeavors. Once on the lunar surface, the crew will conduct a range of scientific experiments, explore the terrain and test new technologies designed to support long-duration human exploration missions. It will also include the deployment of scientific instruments such as seismometers and drilling equipment. The experiments aim to study the Moon's geology and better understand the early history of our solar system. NASA sees Artemis as the next big step towards the long-term goal of establishing a sustainable presence on the Moon. In 2028, they plan on launching the Lunar Surface Asset, a small habitat on the surface of the Moon. Very ambitious and well, kind of scary. It seems like politics are already a thing even in space. You can tell that the fight for the resources of the Moon has already low-key started. What's going to happen next? Well, we will wait for another 10 years and hopefully witness everything with our very own eyes. The race is on. The winner is unknown. Yet. Who are you going to bet on? Next, we're going to tell you more about the Artemis mission and what exactly the USA wants to achieve with it.